We already dealt with transformations at the beginning of this year. Now we need to specifically talk about transformations of quadratics. So what I have written here are the two forms of quadratics that we're going to be talking about. Okay, we've got vertex form and we've got standard form. Now, in vertex form, we've got an A, a B, an H, and a K. Right? What you need to know is that when we're talking about transformations, even though there's two forms of quadratics, we typically only talk about transformations in vertex form. Okay, so I'd like to define for you what the A, the B, the H, and the K mean. Okay, first of all, hopefully you'll remember the H and the K, because that was something that we talked about at the beginning of the year, and we went over quite a bit. H is going to stand for a horizontal shift. Okay, remember, F's are important. Remember, I even know that, right? Okay, the K is a vertical shift. Horizontal shift is moving left or right. Vertical shift is moving the parabola up or down. Okay, the A and the B we also talked about at the beginning of the year. We actually talked about the A a whole lot more than we talked about the B. All right, but the A, just like the K, the A is outside of the main part of the function. See this thing being squared? That's what makes it a quadratic. The A and the K are both outside of that. And so anytime it's going to be outside, it's going to be something vertical. Something being added or subtracted outside is a vertical shift. Something being multiplied on the outside is a vertical stretch or compression. Okay, vertical stretch or a compression, which hopefully helps you realize what the B does. H and the B are both inside of the function. H causes a horizontal shift, so the B, hopefully you realize, will cause a horizontal stretch or compression. Okay? Now, there is something special about A that we didn't talk about real quick. Notice what I have written out in front, a plus or a minus. The A also, the sign of the A, will help you realize if the parabola, which is what a quadratic makes when you graph it, it'll tell you if the parabola opens up or it will tell you if the parabola opens down. Okay? So if this is positive, if A is positive, it's going to open up. And if the A is negative, it will open down. Okay? So what I need you to be able to do is I need you to be able to look at some equations and tell me if they're opening up or down. And I need you to be telling me how they are shifting compared or transforming compared to the parent function. So look at this equation. We have something inside, a 6 inside, and if you'll remember from the beginning of the year, if it's inside, it's really opposite of what we think it should do. So this is going to be a horizontal shift. It's negative 6, so we think it should go left, but that means it goes right. 6. Okay? What about this one? Y equals x squared plus 4. Well, it's outside of the main function, so that's going to cause a vertical shift. And this moves exactly how you think it should go. It's a vertical shift up 4 because it is positive 4. Okay? Y equals 4 times x plus 3 squared minus 1. So hopefully you realize this is doing more than just one thing. Okay? So the best way to figure out what's going on is just kind of start from left to right. And we'll, as we get to something that we think is causing a transformation, we'll decide what it is. So where there's a 4, it's on the outside of the main function. So that's going to be a vertical. It's either stretch or compression. Remember from the beginning of the year, this is greater than 1. So that's going to cause a stretch. And we say it's by a factor of 4. Oops, sorry, by a factor of 4. Okay? Now, so going from left to right, we took care of the 4. Then we have something inside of the main function. So that's going to cause a horizontal shift opposite of what we think it should be. So left 3. And then we have a -1. So vertical shift down 1. Okay? Last one. Y equals -1/2 times x minus 1 squared. Well, negative is going to cause a reflection over the x-axis. Now, when we talked about it earlier, we said it either opens up or down. Can you see that that's the regular parent function, and this is a reflection over the x-axis? Okay. Then we have a 1/2. That's a multiplier on the outside. The multiplier, however, is between 0 and 1, so we say that it is a vertical compression by a factor of 1/2. And then we have a -1 on the inside, so that is a horizontal shift opposite of what we think, so right 1. Okay. The other thing I want you to be able to do is look at the transformations and be able to give me the equation that it comes from. Okay. So I know that we have y equals a times bx minus h squared plus k. So if it reflects over the x-axis, I know my a value has to be negative. Now there's no compression or stretch here, so I know that I don't have a value for A. I also know I don't have a value for B. I do have a horizontal shift, and it's going left 2, so I should have x plus 2 squared. And then I have a vertical shift up 3, so plus 3. Okay, one last example. Vertical shift down 1 and a vertical stretch by a factor of 5. Using this as our pattern that we are working with, we don't have a reflection of any kind, so I know my A is going to be positive. I do have a vertical stretch. If I have a vertical stretch, that's going to be something on the outside, because vertical things happen on the outside of the main function. So my A value is going to be a 5. I don't have any sort of horizontal changes, so I'm just going to have x squared. And then plus k, I do have a shift down 5, so minus 1. Now, I think the most common question I get about this situation is, what does the square do? What does this 2 up here do to all of this stuff? Well, remember, our main function right here, that is our vertex form of a quadratic. That 2 makes it a quadratic. So it doesn't cause any transformations. That is what gives it its main shape. Okay? I hope you have a great evening. If you would like to do some extra credit this evening, you can show me before you get to class tomorrow, or sorry, not before, but when you get to class tomorrow, you can show me page 59 in your workbook, 1 through 7. Okay? If you want to do some extra credit, you can do page 59, numbers 1 through 7. Otherwise, I hope you have a great day, and I'll see you tomorrow.